What's up, folks? Welcome to another episode of the Compile Swift podcast. I have a very special guest with me today. We've been trying to work this one for a while, and I'm pretty excited about this. We're going to talk about a few multiple subjects here, but I'm not going to leave you guessing any longer. My special guest here, please go ahead and introduce yourself.
Hey, I'm Joannis Orlandos. I'm a Swift member of the Swift Server Workgroup, which means I've been involved in Serverside Swift. I'm also doing iOS development. I've been a member of the Swift Vapor core team. I'm known for MongoKitten, some work on the SSH client and server, and recently Hummingbird too.
Great, yeah, so many wonderful subjects to talk about here. Swift Server Workgroup. Talk to us about that, because I think that this is something that I'm aware of. I know many other folks are aware of, but a lot of developers coming to Swift still think of it as, that language you make iOS apps with, and that's true. But it doesn't end there. Swift actually reaches out a lot further and does some great stuff on the server. So talk about the Swift Server Workgroup.
So Swift as a language is very ergonomic, as most of you will know. And ergonomics is really, I think, one of the key features about Swift. But Swift is in a very niche, unique position where it's used for systems programming. On macOS and iOS, you can make apps with it, but it's a compiled language. It has predictable performance. It's ergonomic. It's always good quality to have ergonomics in your language, right? It's very easy to write Swift and get to learn it. And it has this interesting feature called incremental disclosure, where you start out with the language as a beginner using just your normal types everyone uses, like structs, classes, and that's it. But as you dive deeper into specific needs that you have within the language, it expands your horizon. So if you need to do low-level operations, you're talking to a C library, or you're talking to even embedded stuff, you can grab for unsafe pointers, which allow you to use write pointers the way you would in C and C++. Likewise, there is C++ interoperability in case you need to interface with those system libraries. And these are all really helpful features that exist beyond Swift for iOS and macOS. They're really helpful for networking applications, writing cloud systems, databases like Foundation Database, FoundationDB. Apple is writing distributed systems using Swift, which is just a backend thing for the most part. We're using it to write Lambdas on AWS Cloud, regular Docker containers that run on the cloud, and even Raspberry Pis are being programmed with Swift nowadays.
Funny, I was reading an article the other day. Someone was talking about putting, on a Raspberry Pi, and that one had never even occurred to me. And of course I was pretty excited about this. I've never worked with Raspberry Pis outside of, quote, day job work. And it got me to thinking of all the projects that I was like, I could you do this around the house, put Swift on the Raspberry Pi, solve the problem, and also as well, I've got all these old, I'm sure we all do, these old machines laying around, and I'm thinking to myself, I could put Swift on there and have my own little stack in the house here, and work with that as well, because we have so many options, and Swift on the server, very popular for those folks who have used it. You hear nothing but good news. I know some folks who do everything with it, and you can even put out websites. There's many frameworks out there now for blogs and things like that as well. And I know you mentioned working on Vapor, part of the Vapor group,
yes,
as well, which of course is a very well known one, and you often hear that mentioned. I myself have played with Vapor and liked it. Now you reached out to me. Gosh, I can't even remember how long ago it was we started talking. And you mentioned Hummingbird, though, which I had not heard of. and this caught my eye, and I've sort of been quietly sitting in the background, keeping an eye on it, and it's growing up very, very nicely, and it's also got a catchy name. That always helps, right? Having a catchy name.
And it's a bird.
But yeah, and it's a but yeah, exactly. We're keeping it in the family here, right? But tell us some more about the pros of using Hummingbird too, because this project is definitely something that's like, okay, I'm trying to find myself something to build to play with it, and I think I've got a couple of personal projects I want to do. But talk to us about Hummingbird for those who don't know what it is.
So Hummingbird is another web framework for Swift. Initially, it started out as sort of a fork of Vapor 4 at the time. Vapor, if you're not familiar with it, is a very big framework. It has a lot of features. The downside of those features is that all of those need to be compiled. So if you're not using HTTP2, if you're not using TLS, if you're not using decrypt for password hashing, like all of those features that you don't need, they're still being compiled. They still take up binary size, which matters sometimes in the cloud. They still take up compile time. Your development time is influenced by that, and there are dependencies. Hummingbird 1 is just a split up of those modules from Vapors, from what was around in Vapor time. So essentially, that's really nice, right? So it's just an incremental improvement, a slight one. That's a breaking change on top of Vapor. With Hummingbird 2, I actually reached out to the creator of Hummingbird, Adam Fowler, and we talked a lot about where server-side Swift is at now and where it needs to go. And we had these partially the same, some conflicting ideas and some aligned ideas where we thought, okay, this is kind of what we think, it's where we think server-side Swift is currently lacking. And a couple of those that we identified, we tried to tackle them as best as possible. I think Adam has been tackling some of them already really well. So Vapor has a lot of content out there already on like Codeco, in some books that people wrote. And it's just amazing, but it's not very accessible. It's not centralized. The main documentation on vapor.codes has always been our weakness since I worked there. It covers the basics, but it doesn't go very well beyond that. So Adam Fowler has been making a really good effort, putting time and effort into documentation for Hummingbird, and it shows. There are great examples. There is a large variety of examples. You can use it as a Lambda. You can use it with Open API Generator, etc. And we continue the story into Hummingbird 2 as well. Where things take an interesting turn is, if you look at the history of Vapor started out, Vapor 0.3 is when I got involved, basically the first alphas. It was a very basic web framework where they implemented their own HTTP parser. And then when they got a sponsor, Tanner and Logan at the time worked on building that framework out with Fluent as an ORM. Then in Vapor 2, it was just an incremental improvement on top of lessons learned from building your first web framework. But Vapor 2 was not the fastest. It was more comparable to PHP at the time, and PHP at the time was way worse than it is now in terms of performance. So this is kind of where I come into the picture. I've already been building other libraries like MongoKitten for years at the time, and I had experience optimizing database drivers. So I collaborated with them to build on Vapor 3, which was using asynchronous networking. And we just tweaked the hell out of everything until it's at the pace of at least Node.js and faster. And that worked, but Vapor 3 was received really well. And this sounds like a dream, right? Your web framework is received like everyone wants to use it. The problem there is that Vapor 3 needed to be released very early. Everyone was using the breaking changes, the alpha builds that were breaking every week. They were using it in production because they couldn't wait. So we had to cut breaking changes short, and we moved into the beta phases early, and then also had to move into release early. So we weren't done polishing, not nearly. So that's where Tanner continued polishing it for Vapor 4, and that's released. Now, Vapor 3 and 4 were created at the time when Swift Neo was brand new, and actually during Vapor 3, Swift Neo didn't even exist. Swift Swift has been every year on year a very different language. Things have been evolving very quickly. But one thing you'll note if you look at the timelines is that async await structured concurrency wasn't around yet. So the comforts of writing concurrent code weren't in the language yet. So we were using futures and promises to work around that, or kind of. Now today is a completely different story, but Vapor 4 very much still has a core that is written based on the lack of structured concurrency. So it completely relies on event loop futures and promises, and has race conditions all over the place that the compiler simply didn't know about back in the day. Now with Swift 6 coming out, we do get a lot more diagnostics about what potential race conditions are. And everyone has just been finding issues to fix left, right, and center, but that's not for the better of performance. And it complicates the system, so it makes it very hard to maintain. So with Hummingbird 2, Adam and I decided that structured concurrency needed to be adopted fully or not at all. And the only way within Swift is to adopt it fully. So we rewrote the engine based on structured concurrency. We use modern Swift Neo standards that are based on structured concurrency. And the performance is just, if you compare it to an apples comparison, it's 2.5 times faster. The code is much more maintainable because it supports structured concurrencies. You have task locals available. They propagate just like you expect them to. There are very few downsides at the moment, although Vapor 5 will be a response to this as well, coming somewhere later this year. But Hummingbird 2 is now out there. It is in beta formally. We do expect we might need a breaking change here or there, but over the last 4 months or so, that has been very minimal.
It's an interesting challenge, right? Because, like you say, I think pretty much as you say, the history of Swift in any form has always been a moving target that we have been chasing, right? I'm sure anybody that's been around with Swift for a while immediately goes back to their Swift to version 2 to version 3 years and how much fun that was. And we all sort of, joke about it a bit, but it is a growing language, right? At that time, it was very early. And I think, we all knew going in that it's like, this is going to be a little bit painful at first, but, it's kind of hang in there.
It's worth it.
We'll get there. Yeah, it's absolutely. Yeah. And it's interesting because I was going to ask you, from the perspective of, Vapor and Hummingbird and that, how you plan or try to plan to catch some of those moving targets along the path. Now, interestingly, one of the topics we are going to talk about here in a little bit, Swift with the concurrency, definitely plays into something. I'm sure you are like, great, we finally have what we need, right? And with that becomes, okay, do we do do you start from scratch and say, okay, we're going to target this specifically and take advantage of this and let the legacy go, or whether you try to embrace it along the way and sort of move along the path together with the language as it progresses, right? And like you say, Swift 6 around the corner, rumor is it's going to be some very different things in there. We're going to have to adapt our code again, all for good reasons. But it is that next level of, okay, here we go. So how do you try to plan for that? And, do you sort of play safe sometimes and say, okay, these parts, the language are very mature. We're gonna go with these and take some of this. I don't want to use the word experimental, but early release changes. Or do you just plan and go all in and say, okay, by the time we want to release this version, Swift should be at version X, and therefore we're safe to use these particular parts of the technology?
It's actually, interestingly, a combination of all of the above. So whenever someone at Apple proposes a new feature that they plan to release into Swift, we I usually download the toolchain immediately and try to see how it benefits the tools and libraries that I'm working on. I'll try to see how it can benefit my clients, even like all of the across all of my projects. And I do give them valuable feedback whenever I have it, so that we can improve their feature design, but also make sure that it fits our use cases. And sometimes my feedback doesn't fit the scope of a feature, but they'll add a new feature to accommodate the requests. So whenever a feature comes out, yes, I will switch the switch to see if I can adopt it as soon as possible. But if I have a current stable release, I'm not gonna break for it. But I'll see if I can accommodate that feature. I can accommodate room in my design so that that feature can be fitted later. Good example is task executor preferences. So Hummingbird 2 right now runs when it uses task groups and discardable task groups to queue work using structured concurrency mechanism. But spawning a task happens on the global concurrent executor, whereas we know as framework authors that this is a TCP connection we're listening to, which belongs to Swift Neo. And Swift Neo has an event loop. So we'd like to use that to offload, to minimize the performance impact of jumping between threads. Now, this is an optimization that we can do within the framework, but we need to be careful about how we design it. So in our case, we are preparing for the fact that task executor preferences are going to be there. And we can get like a 5 or 10% performance bonus there by adopting that. So yeah, we're very conscious about that. So we're taking that into account right now. And we have a PR ready for whenever the feature lands, but we're not publishing it yet because the feature needs to be in Swift first and finalized.
Nice. So this is a case of you're waiting for everybody to catch up with you, right? It's like, okay, great. Now we can give you this,
so.
right?
Yes.
This is good, though. I mean, and I mean that in a good way, because it's nice to be always, as developers, a lot of the time we feel like we're either struggling to stay on the curve or behind the curve. So anytime you can get a bit of a jump and you're like, okay, we can plan for this. We're going to let it sit. We'll wait for it to bake in the language. And then, great, our work here is done and we're already on to the next thing. That's a huge win right there, especially for something like this. Like you say, those early adopters, right, who put things in production. It's like, look, we said this wasn't quite ready, but they put it out in production, and then they hit an issue, and it's that nice way of sort of pointing out. Did you read the documentation where it said, look, don't put this on the server yet, right?
Mm-hmm.
And we should point out to folks, there'll be links in the show notes here to GitHub with all the Hummingbird repos. Because you have them nicely broken down as well. I got the list here in front of me. You've got different repos for different parts, right? You've got the core and the authentication and the WebSockets and ports like that. So folks can follow along with this and dive into the repo. And presumably as well, I'm guessing you're always happy to take contributions, pull requests as well, right?
Yeah, totally. And feedback as well. I think not everyone realizes it, but a good way to help a project, an open source project, is not always through contributing fixes or code. It can also be feedback. It can be, hey, do you know about this missing documentation? Or maybe even providing some documentation. Like, there are so many more ways to help a framework than just contributing fixes to it or features. Another good way to help a community and ecosystem is by making tutorials or by writing a blog post about how you're using Hummingbird. So there are definitely other ways to help an ecosystem like this as well.
Oh, absolutely. And I'm glad you mentioned that, because, a lot of people, as soon as you say like contributing to open source, they immediately think coding. And then, if you're like me, you immediately think people don't want to see my code. It's embarrassingly bad. But there are so many ways to contribute. I would imagine, and to bring your special skills, right? Because there are folks out there who love all sorts of things, like you say, writing documentation. Yes, okay. Traditionally, as developers, we're not big on, I'm going to write documentation today. But there are folks out there who love to do this kind of thing. Like you say, tutorials, I think, is a huge important one. I
And your
know for
name is on the
me,
tutorial.
yes, exactly, yeah. Because anytime I come to a new product, new framework, immediately I'm looking for like, okay, great, I have a wealth of technical information, but sometimes it's just nice to pull down a tutorial or an example, run it, and almost learn it, through reverse engineering, so that you can map that technical side to an implementation and come up to speed that way. So that, yeah, folks, there are so many ways you can contribute to these products. You don't necessarily have to write code if you're not comfortable with that. There are so many other ways, and like you say, reporting features, bugs, um, even just promotion. Like we're doing here in many ways, promotion of these
Yes.
repos and products as well. Getting it out there to the folks who don't know about these things.
Time for a break.
Hey everybody, it's Peter Whittam here from the Compile Swift podcast. I'm going to tell you about SetApp. SetApp is a service that provides a subscription fee of just $10 a month, and you get access to over 200 Mac applications, and it's also available now on iOS as part of that deal. I use the service because it just has a ton of really good first-rate apps that I use all the time. And for me, it's invaluable as a developer to have access to tools for things like APIs, for planning projects, writing emails, writing documentation. And you can get all of these things, including database apps, all of that kind of stuff, right there on the SetApp service for just $10 a month. You can use as many or as few applications as you need. If you're interested in checking this out, go to peterwitham.com, peterwitham.com/SetApp, SETAPP, and you can see the details there. And it's got a link that you can go over and start using the service and see how it works out for you. I strongly recommend this to every Mac user.
Break time over.
So I do want to ask, we've mentioned it a couple of times, and a lot of people are talking about it. So, if you were like me at first, you heard the words structured concurrency, and you're like, what? And since then, of course, it's rapidly growing in popularity in Swift now that other languages have had it. So. Talk to us about that, because we'll put a link in the show notes. You did a great blog post that I actually read a couple of times to make sure it sort of sunk into my head. So tell us about structured concurrency in Swift, and why it's good that it's here now officially, and the benefits that it can bring for us.
So structured concurrency has been around since Swift 5.5, but it's only gonna be magnified in significance with Swift 6. So for those unfamiliar, Swift 6 is going to be I would probably call it the structured concurrency release. Not because this is where it's introduced, but this is where it's kind of in its final form. It goes Super Saiyan. So, I mean, structured concurrency was already around in many ways since Swift 5.5. You have async await, you have async streams, async sequences, like many of the basic building blocks that you as a user will be using, like you as a programmer will be using in your applications, were already there. But mainly for framework developers, library developers, and people like Apple themselves, a lot of nuances were not right yet. And there is one particular area that wasn't completed yet. So like I said, the task executor preferences, these optimizations that we can make, these little bits of control that we can have over how structured concurrency operates and performs, these are not, these weren't fleshed out yet, these weren't available. So with Swift 6, all of that will change. But there is one major topic that wasn't ready yet. Even if the language features were there, the language compile time wants to guarantee, just like it guarantees that a string is not an integer, and no, you can't compare them, and no, you can't override the variable, just like that. Like under that same concept, structured concurrency aims to ensure there are no race conditions. That's the basic premise. When you call into structured concurrency code, and Swift is able to check it with sendable and stuff, it will try to guarantee for you that your code will not have race conditions. It will not have like crashes because you accessed state from two different threads. And a large variety of bugs that fall under race conditions are going to be resolved. So, but interestingly enough, I think structured concurrency is another type of race condition that's not the typical crash. That is also that is not resolved by structured concurrency, but that structured concurrency really helps with. And that's kind of like just a mindset that you need to get into. So with Swift 6, they're going to be activating all of the sendability checks, like all the alarms and whistle and bells are going to be enabled. Whenever you have one race condition in your code, and structured concurrency with Swift 6 is properly applied, you'll have no error. You'll have no errors, but one race condition will trigger the compiler to not compile your code. And it's great, right? You're going to be, I mean, compared to Android apps, you're going to be having a great crash-free user ratio. But then there's the second class of race conditions that I think is underappreciated. So, of course, crash-free users are great, but bug-free code is greater, right?
Yeah.
And a lot of race conditions, they originate not necessarily because you because you access state at the same time. I mean, structured concurrency and actors do provide a really great solution on fixing that. But I think more interestingly is also that there are a lot of patterns that people that teach structured concurrency in blog posts and articles they focus on the crashing bit. They don't focus on the logic side of things. Because when you look at concurrency, we're really talking about basically running something in the background most of the time, like your foundation URL session, where you try to do an HTTP request and get a response back.
Yeah.
But the structured bit of structured concurrency is that you read code top to bottom, just like your if statements would. So in structured programming, you write constructs within a function, and these constructs are done by the time your function ends. So like a return statement could be an early exit still. And just like in structured programming, when you throw an error or a turn, it affects the flow of your application in an expected manner. So you can literally read your code top to bottom. If you don't write structured code by spawning tasks, like the task type that everyone tries to grab for, you lose the benefit of the structured part of structured concurrency. And I think it's just really unfortunate that detail, which is really important, is being overlooked.
I know that I'm guilty. I'm sure many other folks. I'll admit it on their behalf. In the real world scenario, you find you have these race conditions, and you're sitting there looking at it thinking, yes, it makes sense on the screen. When I read the code, it makes sense, but the code doesn't necessarily execute that way, depending on various situations, especially if you are doing things like, some heavy lifting on mobile apps. And at that point, you are heavily reliant on network connection, right? And the reliability and the speed of that network connection. And it's kind of like a defensive programming technique, I think, in many ways. Always assume that you are not going to get back in a logical, sensible order that you think you should, right? Yes, on the screen it looks great, but in the real world, calling out to those servers may not go in the order that you expect. And a bit of defensive programming technique in there, having these in the Swift language is only going to make that even better. And anytime you can reduce your crash rate, even because some folks look at it and they'll say, a race condition is not a crash. Well,
it doesn't have to be a crash. But if you look at the reason I named Android is because I think the interesting bit here is Apple is really pushing for native apps, and there's a reason for that, because the native language for building native iOS apps is Swift, and Swift is in Apple's control. And it doesn't mean that Apple wants you to write Swift code because they think Swift is in their control, but it is in Apple's best interest that you use the tools and techniques that you provide them, because Apple wants to improve the quality of those tools in order to create a better app ecosystem.
Yep.
So the better Apple makes Swift, and the more they ensure race conditions are out of your apps, the better the quality your apps will be, which means that Apple has a better offering in terms of apps. I
Yeah,
mean, that's the way I
absolutely.
look at
Yeah.
it, right?
Yeah.
But when I mean, what you said was really interesting, where you said that if you make 3 network calls, you don't have the guarantee that they complete in a certain order. And sometimes that matters, and sometimes it does not. So, for example, when it doesn't matter which completes first, which response arrives first, or which request is sent first. So if you need 3 images for profile pictures, and you want all of them to complete before you render it, you can do an async let before the HTTP call, and all 3 of the async lets will run in parallel. And then you await all 3 of them when you're ready to process the result. I think that's just brilliant. It's a super simple pattern. It reads top to bottom. You await the async let whenever you need it, and that's it. That's structured code, and it's concurrent, and it's performant. But I really want to go into detail about this one if you don't mind.
Oh, please do.
Because
Yeah.
it's very difficult, and you've seen this in my guide. It's very difficult to explain structured concurrency as a topic in segments. So my tutorial is pretty lengthy. I managed to cut it up in 2 parts at least. I'm happy about that. But I was initially planning to make it a 4 or 6-parter, just to keep it concise and manageable. But I found that the more I try to separate the article into multiple pieces, the more I would have to resort to plug holes basically that were incorrect. So if you want to spawn concurrent work without an async let because you didn't explain async let, then what is your solution? It's going to be an unstructured task. So you create a task with the task type, you write your code in the task block, but my tutorial was very explicitly designed to avoid those at all costs. And if you read my article, then you'll know a bit more about why. But I'll still explain it, because when you have an unstructured task, which is the task type with a capital T, this spawns will not work in the background. If you don't capture the task and you manually need to, then you can manually observe the value, but there is no need for you to catch the error. So you lose the error throwing bit of Swift, which I think is dangerous, right? The error propagation is a part of the language for a reason. And I think just like people, whenever the compiler complains that you can't throw in a function that is non-throwing, it tells you to put the exclamation mark, or at least it used to do that, right? So it says, hey, did you know you can crash your application if you put this exclamation mark there? And it's a super quick fix. And back in the day when the default behavior of Xcode was to provide this fix-it, a lot of apps were crashing because of it, like in really odd scenarios, because nobody was able to catch the errors and handle them correctly. So I think that I'm really happy that this has been properly communicated in the community, that like crashing your application is not the desired behavior, and that's what it does. It's not a quick fix. Yeah. And I think likewise, spawning unstructured tasks is not a quick fix. Because yes, in a way, I mean, it is a quick fix, but it's not a fix. In a way, yes, it allows you to spawn unstructured code, like unstructured async code from within a SwiftUI button. But you lose one important detail, which is knowing when the function starts and ends, when the order of execution of your functions. So I actually had an app for a client that I work with. They're an Apple Design Award winner called Audio. And their app is pretty interesting. It's spatial audio, where you can move audio nodes to like specific location and hear them around you. Like I want a waterfall there in the room. And we redesigned their entire audio engine based around structured concurrency. And we managed to cut down, and we did this on purpose. We managed to cut down our business, like the unstructured tasks in that app, to a total of 3. One was mandatory because we needed to spawn structured concurrency code. Okay. But the other 2 unstructured tasks were not necessary, just pass code review because we didn't pay attention. And I think it was pretty soon that we found out that there was a bug in our code. And I didn't even need to, it was really weird because things were being done out of order where functions were being called to add something like add a waterfall in the back of your room and then remove it because you didn't want it anymore. And for some reason, creating the node in the back of my room took longer than like a couple seconds. Maybe the disk I/O was busy. And then you remove the node within those couple of seconds. So it tried to remove the node before it was done adding the node. That was a classical race condition, but it didn't crash. So we didn't have any logs to go on. And then when I looked at the state, the function that spawns these nodes and removes the nodes, that was an unstructured task that was calling that function because we were observing events from Combine. Your gesture that was dragging the items on and off the screen was a Combine publisher. So we needed to map that to structured concurrency, and we used sync, but sync is not an async function, so it was needed a task to emit that event. So we redesigned that entirely so that we could observe those events using structured concurrency, which is, by the way, super simple. You just observe the values. There is a property on publisher called values, which allows you to for loop over them. It's amazing. Like Combine already works really well with structured concurrency, but just fixing that issue, just removing the unstructured task was making sure all our issues were gone. And yes, Swift 6 fixes fixes race conditions in crashes, but there are still so many more. So I hope that people will be able to get the hang of how to build apps without unstructured tasks. Because I think all of the blog posts that I've seen complaining about structured concurrency were using unstructured tasks all over their code base.
A lot of the times when I hit problems, I've not paid attention and essentially backed myself into a corner where I then realize, oh, it's a race condition. Now I got to figure out how to get out of this. And it's interesting that you mentioned, how a lot of the times it is folks not looking at it and recognizing and realizing that, if you structure your code. Hey folks, if you like what you're hearing in this podcast and you want to help this podcast to continue going forward and having great guests and great conversations, I invite you to become a Patreon supporter. You can go to patreon.com/CompileSwift, where you will get ad-free versions of the podcast along with other content. Accordingly, you're preventing this problem further down the line.
I think maintainability of your code base is crucial. I think every developer is guilty of this. And since I started Swift, I think by now almost 9 years ago, I started Swift, like 2015. Yeah, so when I started Swift, it took me a long time to become disciplined enough to stop cutting corners. And I see myself do this everywhere. But I've got a co-founder now, and we together advise a couple of businesses, like one that will be speaking at the Meetup that we're organizing as well. And there are a very, very, very bunch of the businesses, but the only common denominator is that they use Swift. And we try to, we have this review process internally where we have me, my co-founder, and a junior developer. And I think all of us are critical in the process of ensuring our code is clean. Because when I create code, I read it myself first, and I try to envision what the other two will think about my code. And then when Robert, my co-founder, sees my code, he's very, very critical. Robert and I always ensure that the other does not do any quick fixes, or at least document them extremely explicitly, adds an issue in our issue board to resolve it, adds a warning in Swift, because, with the compiler, you can make a compiler directive, put a warning there, because we have a zero warning policy when we have a release it build to a client usually.
Nice.
We know that this needs to be fixed. We know this needs to be addressed. The only reason we're merging it now is if we need to move forward, because, the client wants to see results. And then finally, after removing or documenting all quick fixes or workarounds, we go to the junior developer and ask them to read it. And the junior developer has two reasons to read this. The first one is they learn a lot from it. They will be able to ask questions. They will be able to dissect what I did and how I did it. So it's very educative for them. But that's not the main reason. I'm not, well, I mean, it's a really big reason for me as a business owner to involve them. But even as a senior developer, the main reason I want him to read my code is because he's going to ask questions. Not the questions that I need to answer. No, the questions that show me that my code is too complicated. So if my junior developer is not able to understand the code that I write, then that's a really bad sign of the quality of code that I'm delivering. It might be super functional, it might be super performant. Everything objectively might be great, but if he doesn't catch on, then it's not maintainable.
That's a really, really important point right there, folks, because it's important that we check other folks understand what we're doing, because something that I try to sort of mentor into folks is always assume someone else is going to be looking at your code, and it might be someone who can just read it, fully understand what you've done, especially if you super optimize that code, right? And it may be completely readable to them, but somebody else may look and have questions because their experience level is not quite at the point that they can put all of this together. And one of the ways that I express this to folks is, in order to prevent you being the one that gets the phone call 3:00 in the morning when something's gone wrong in production, if you make it that other people can understand it, there's less chance of you being called.
And also, when you leave your job, when a new team member gets hired, or when you get promoted, which means that you get to spend more time on extremely exciting new challenges, and the other people are staying behind to maintain what you created. I mean, there are so many scenarios where you need this. The only reason you wouldn't want to do this is because you're a solo developer, and then even still.
I think, that is something I've been speaking about recently, and because I do have opinions on that, because I have working on a project, a personal project maybe, and then it goes to the wayside for a while, a couple of months, something like that, maybe longer. And then you come back to it and you spend an enormous amount of time trying to re-educate yourself on your own code base that you wrote and why you did these things. Maybe you didn't document them. I hear that happens sometimes. But so being a solo developer, I think you should definitely treat it the same as when you're working on a team. It's just, as some folks say, and I think it's a wonderful phrase, it's helping the future you that's going to be coming back to this, right? But it's also important, because I want to touch on this because you mentioned this in the last interview I did with Matt from SEMA Software, and he was saying, how critically important it is developer retention, so that knowledge remains in a product, in a company, in a team, because of this problem, right? Once that developer moves on for whatever reason, you're hoping there's enough knowledge in the project that other folks can pick it up and work with it as well, right? So I'm glad that you mentioned that. Yeah.
I think there are two more bits about that. So first of all, when you work for a boss and you create a product, I think most developers have a sense of pride where they're happy that they created something. But if the next developer is not happy with your code, they're gonna rewrite it, and your legacy will not exist anymore. That's just painful, isn't it?
Yeah.
That you worked for a company for 3 years, and whenever you leave, it's all gone.
Yep.
It's just the customer doesn't even use your code anymore because your code wasn't maintainable enough. But also, as a freelancer and now a business owner, it doesn't make sense for me to accept the shortcut. So I sometimes have fixed price projects for clients, and I quote them. Let's say, let's go for a round number like 100. I quote them 100 hours for a feature, and then, but roughly by the end of it, I discovered this major flaw that I like a design flaw I did, and it's gonna put me over budget. So I could do a couple things here. I could accept the flaw and continue with my life, and I'm over budget. Sorry, but I did my best, right? The second option is I could fix the bug at my own cost, or I could fix it at their cost. So I think this, for me, the first option is not an option unless I want to lose my client. And I'm gonna say this very clearly, because if my client decides to stop with me because I made a bug, understandable. If my client continues working with me, I'm still gonna eat the cost, right? Because I'm gonna have to work with my own flaws, like all the design flaws that I implemented in their product. They're gonna come back to bite me, and I'm gonna have to fix them. So option one is not an option unless I plan to lose the client. Option two is I'm gonna eat the cost, and I honestly, most of the time, it's not the best way for a business owner, but we do this quite a lot, and not for a lot of hours most of the time. But sometimes we do lose a lot of money fixing these bugs. But it's also kind of in our price. We're not the cheapest, but we want to make sure that when our clients leave, they leave happy. So if this is what it takes to make a really happy client, then we do this. And it's actually, I think you're just building up karma, and this karma has always come back to meet us. Like clients that we have helped to this degree in the past, we make sure that they know that we introduced a flaw, and we also make sure that they know we fixed it. But and they're really happy because we're reliable. But like, sometimes we go for option three where we say, okay, this was not maybe entirely our fault, or we went way over budget. Maybe we could compensate it a little bit. But then at that point, I have already fixed it, or am planning to fix it. Just a matter of when I can recoup some of the cost. But I think it's just, it always comes back to bite you when you cut corners, especially when you're under budget.
Well, I think too, it's I'm glad to hear you say that, and I hear a lot of folks saying it, and it always, makes me feel a whole lot better about our industry and what we do, because it is that discipline, right? You could find this bug. At this point, nobody else knows about it except you. But because of your self-imposed discipline and desire to deliver the right solution and, a maintainable solution and a good product, you say to yourself, doesn't matter, whether this is covered by the cost or not, I have to fix this, just if nothing else, so that I know that I fixed it. And it's not there for, whether it's for me, for the next person, or whoever. I always think it's nothing worse than you let a product go, you ship it, knowing there's a possible situation. And I get this. It's difficult, right? I have to make these decisions all the time in my jobby job of, is something bad enough that we delay shipping it? Or do we say, okay, it's here, we're going to get it the next time around? And that's always a judgment call. I think eventually you just rely on years of experience to tell you, if it's only going to happen to 1%, maybe, okay, that you should still get this, but get it next time. Don't delay it for the mass, all right? But that discipline, and like you say, the karma of, I just got to do this because it's the right thing to do. All right, here it is, the one thing that I cannot do without every day, and that is my coffee. Anyone that knows me, or anyone that's listened to any of my podcasts or anything else, knows that I absolutely cannot operate without my coffee, and I love good coffee. So here's the deal. I'm going to give you one free bag of coffee by going to peterwitham.com/coffee. There is a wonderful company out there that follows the fair trade practices, helps out a lot of independent roasters of all sizes, and the operation is simple. What you do is you're going to go to peterwitham.com/coffee. You sign up there. You get a free bag of coffee sent to you. Yes, in return, they say thank you to me by giving me some coffee. But that's not the reason I'm doing this. The reason I'm doing this is because I have found so many good coffees that I just would never have come across, heard about, or experienced without this service. Trade coffee is just fantastic. There are plenty of places out there. We all know them that supply coffee, good coffee. You can go to the store, get the coffee, but there is nothing better than discovering new independent roasters and supporting them, discovering new flavors of coffee, new grinds for, you can set it up. It's very smart. You tell it the kind of coffee you like, and over time it gets better and better as it trains in on your selections and your choices and gives you exactly the coffee you're looking for and recommending new ones that will be very similar. Every time I get a new packet of coffee, I go through, and afterwards try the coffee. I go through the service and I say, look, I loved this coffee. I thought this coffee was okay. Or I say, look, this was really not for me. And every time I do that, it makes the service a little more accurate on the next selection for me. So again, just go to peterwitham.com/coffee. Get your free bag of coffee today. If you're a coffee lover, you're going to really appreciate this service. I have been using it for years at this point and thoroughly recommend it. And I love it when I hear folks saying that. So thank you for putting
it proves
that
you're
out.
reliable to clients, I think. So it's
Yes.
it's even even from a business perspective, just objectively, I think the wisest choice. Because when you're creating a business, freelance or otherwise, in software development, you can't go around with a bad reputation that you leave clients in the dust.
Yes.
Like it's the same business choice to be a reliable partner.
Yeah, it's absolutely the right thing to do. I mean, it's, reputation is, everything, as the saying goes, but very conscious of your time here. Is there anything else we haven't covered that you want to cover?
So the Swift Server Workgroup, of which I'm a member, we're organizing a meetup on the 24th of April, and we'll be doing a quarterly one after that. I don't know when this podcast is going to be posted, but we'd love for people to be there.
Okay.
I think just touching back on that client that I mentioned previously, Audio,
Please,
where we also wrote our audio engine, and a couple other clients as well. I think we do this for most projects now. I really like to design my code as a state machine. I took a lot of inspiration from Corey Banfield, who gave a talk at, I think, a 2019 Swift Server conference. And he talked about state machines in Swift, about how they implemented HTTP2, which is quite a complex protocol using Swift. And they use enums to represent state. You can also use structs or a mix of them. And we do the same in Swift Neo SSH, which is the SSH tooling that we use for Citadel. And I actually was involved with the creation of that library. And it's all state machines. And I'm absolutely in love with how easy it makes some of my refactors, because sometimes I need to add a new feature to the state machine. And I just add an enum case, right? Like, hey, there is this new X that I need to, this new X feature that's my app. And I add an enum case or a variable to it. And it's just, especially with enum cases, if I add a new message that I send over the wire, Swift forces me to handle it. It's great. But nowadays, I'm trying to use those patterns using the composable architecture or something similar in iOS. And I'm trying to model my iOS apps as state machines because I can render the state using Swift UI in the composable architecture. And then that makes my views very easy to construct for unit tests, for UI tests, for snapshot tests. But more interestingly, I can test my state machine on Linux as well. I can port my state machine to Android later on, or WebAssembly, or to the backend, or using Adwaita now. I can port it to GNOME on Linux desktops.
Yeah.
And hopefully when the browser company releases their Windows UI kit, then we can also use the same business logic on Windows, right? So I'm trying to kind of decouple my business logic as much as possible from the implementation, even to the extent where I know I'm going to be using, let's say, AV Foundation for audio rendering, but then I make sure that that's a protocol that my iOS app conforms a type to and injects. And this pattern has just been amazing for me.
Very nice. Yeah, isn't it great? It's always amazing to me when I stop sometimes and I think about where we are now and the things that we can do and how quickly we've got there, because it's amazing that, like you say, you mentioned the GNOME desktop, and I read about this the other day. It was the first I'd heard about it, and my first thought was, great, this dream is starting to come true, where I have my sort of my main language that I focus on and like to use, and I don't have to keep switching out as much to other languages like I used to, and that's great news for me as a developer, right? I can stay focused on my language of choice, but also grow with it. The fact that I can just take Swift and say, okay, I can do my projects with this and feel comfortable with it, just because that's my world, right? Other folks, other languages, totally get that. And sure, some folks will say, oh, but other XYZ language, you've been able to do this for years. That's great, but it's not the great solution for me personally. Or maybe, sometimes clients request a particular stack because they're going to take it at the end of the day, and maybe their internal team is comfortable with that, right?
Right. But I mean, when you're, like I said, when you're developing Swift code, you cannot, at least if you don't use AV Foundation as a hard dependency, if you use dependency injection to inject that, and then use like platform implementations, let's say Linux has a different audio system, Windows has a different audio system, you can inject those. But the business logic is just Swift. There's nothing crazy about it. It doesn't have any dependencies, right? If you can write your code as clean and objective as I just explained it, already you can port that code to all of the platforms that I mentioned before. You can port it to Android, you can port it to iOS, macOS, Linux, Windows, maybe even WebAssembly. And then soon you'll even be able to port some of your code to embedded systems. And like one of my clients, the one that will be giving a presentation at the Meetup from Volcom, we've been discussing using Swift for some of the protocol code between different devices, because we have hardware that's written in C and C++. We have some devices that are written in Swift. We have an iPad app, and all of the communication could be theoretically be done using the same code, because C and C++ have interop with Swift, and Swift is not the problem. So if you can do your network protocols, your Bluetooth stack using Swift, you can do it everywhere. Like what you said is pretty interesting, right? Where we have all these different tech choices, but I think soon, not now. I think now is a bit too soon. There are not that many dependencies that do Bluetooth on Android for Swift, right? There are some, but like if you want to interface with Android libraries, there are not that many libraries that you can. If you want to work with Android on Swift, there are not that many libraries. If you use C, C++ interop, of course, that's great. So that saves you a lot of the pains that we would have previously. But like, I imagine that maybe 2 to 4 years down the line, these ecosystems will flourish a bit more, especially now with the platform steering group, that we see dependencies for Windows with Swift, that we see dependencies, packages that you can use for Android with Swift. And by then, I mean, as a small team of developers, you can achieve so much. You just need, because if you're a small company, you don't need a full-time iOS developer for this app, but you do need an Android app, an iOS app, a backend, and a website. And if 1 or 2 developers can provide all of this using the same tools and techniques that they're used to with Swift, I think that's a brilliant time for businesses to start adopting Swift.
Oh, absolutely, absolutely, yeah.
Well, I think we're getting there very soon.
Oh, I do too. It used to be that the norm was to have dedicated groups for a particular tech. Now, like you say, those. I don't want to say they're reducing, but because of these options, you have a core group of developers, I think, on teams that maintain them from end to end, which gives, in my opinion, always a better experience, right? It's not I wrote my part, handed it off, hopefully should go great with the other team who are doing the website or whatever it may be. But to see that end to end gives developers as well a way to learn and understand how essentially the data from their apps, because that's what it comes down to at the end of the day, goes from the beginning, from the user input through to the database or whatever it may be, and all the stack in between. And that makes a huge difference sometimes on how you choose to architect something and, understanding where the potential pitfalls and problems are as well. Right?
Like a friend of mine wrote, like my co-founder actually, also a friend of mine, of course. He wrote a bit of code, I think, a couple of years back, where they had this form builder that they needed, and they ended up making a Swift UI view that represents a form, and they made it a codable enum, the view. So each of the components in that form was an enum case, and they just had an array of these enum cases that they were rendering, and then they could decode this entire view from JSON and show it to the user. I thought it was brilliant. So I think if you have like platform specific UI desires, you create your UI pattern that same way using Swift on Windows, Swift on Linux, Swift on Mac OS, etc., Android, and you use the platform native preferred technique for rendering. Like Android has a different navigation style from iOS, different from Windows and Mac OS again, and as you can really quickly, I think, iterate on top of that once we get to that point.
Anything else here you want to cover?
I guess one thing. So the Swift Server conference is coming to
absolutely.
London. So Serverside Swift.info is a conference which is created by Tim Condon, which is now a core team member or the core team member of Vapor, maintains a project, is also a member of the Swift Server Workgroup, and I think almost everyone from the Swift Server Workgroup will be there. Most of the open source maintainers that you know from various places at Apple, various open source projects, you'll see all of us around there. And I think if you're interested in coming there, make sure you buy a ticket and visit us in London later this year.
Oh, absolutely. Yeah, go thank everybody for all the hard work they do, right? Greatly appreciate.
And learn a lot. There are always very technical talks. They try to keep it a bit accessible, but there are definitely technical people in the room. So
good. Well, hey, I mean, the great news about that is, as well, though, is you can get to go and talk directly with the folks. Thank you so much for reaching out to me and for making this, a slot available for us to get together and talk about these fascinating subjects, interesting subjects. And the audience has been asking about this as well. Reach out to the links, and hopefully they've enjoyed the conversation. I know I have. It's been great. I knew this was going to be a really good one, and I was super excited we were able to make it work. But please, please, please tell folks where they can find you and anything that you want to point them to.
All right. So you can find me on X or Mastodon under the name Joannis, similar to my GitHub username, JOANNIS. I'm co-founder of Unbeatable Software, which is a Dutch company where we create and guide iOS developers, backend developers, all Swift developers to achieving their goals. We help with training. We do some weekly calls with some companies where we guide them through their issues and try to refine their everything around how they develop Swift code, basically. So if you're interested in that, definitely reach out to me.
Yeah. Joannis, thank you so much, my friend. I was just so excited about this one. We've been trying to put this one together for a while. He's a very popular
6 months.
guy. And, so excited. And hopefully you're welcome to come back anytime. And I've thought of my project that I want to use Hummingbird for. So, I guess would it be fair to say I should go straight to Hummingbird 2 at this stage, or? Oh
yeah, totally. Yeah. I think if you're not starting with Hummingbird 2, you're gonna be in for.
You're living in the past.
It's just a straight. You're living in the past. Yeah, you're living way in the past.
There you go. Yeah. So you heard Joannis told us, hey, stop living in the past. Go to Hummingbird 2. But no, I have an idea for a project that I want to do. So I'm sure I'll tell folks more about that in the future and how it's going. So I may reach out to you as well and say, like, hey, I've done this stupid thing. How do I get out of this? But
hopefully there's not too much of that because the docs should be pretty clear. But still, hey, I mean, if the docs are unclear, be sure to send us a question or
oh,
question
absolutely,
because
absolutely.
that's contributing.
Yeah, there you go, right, folks, and we'll go to the Discord as well, right? Very great place as well. They're all there. You can reach out to them. So, folks, that's what we got for you in this episode. I hope it's been helpful. I think it's been helpful to me. I'm hoping that it's inspired other folks to go and look at stuff as well. You know where to find me. Go to compileswift.com and all the usual places. And with that is what we got for you. Thank you.